Good morning everyone. We are the Group 1. Today, we will show you the evidences that ALFRED WEGENER provided to support his claims. So, without further ado, let's start.
In 1912, Alfred Wegener, a German meteorologist, proposed a theory that about 200 million years ago, the continents were once one large landmass. He called this landmass Pangaea, a Greek word which means all Earth. Wegener searched for evidences to support his claim. He noticed the fit of the edges of the continents on the opposite sides of the South Atlantic. His evidences to the continental drift theory includes the distribution of fossils in different continents, rock features, and ancient climates. Let us have a further study on these evidences. First evidence is the continental jigsaw puzzle. The continents were once a large landmass called Pangaea. The most visible and fascinating evidence that these continents were once one is their shapes. The edge of one continent surprisingly matches the edge of one another. South America and Africa fit together, India, Antarctica, and Australia match one another, Eurasia and North America complete the whole continental puzzle in the north. The next evidence are from fossils. Fossilized leaves of an extinct plant Glossopteris were found in 250 million years old rocks. These fossils were located in the contexts of southern Africa, which are now segregated from each other by wide oceans. The fossils are unable to travel a long journey by the wind or survive a rough ride through ocean waves. The third evidence are from rocks. Fossils found in rocks also provide evidence that supports the continental drift theory. How come these rock layers in different continents line up together with layers that exactly matched? The folded Cape Mountains of South America and Africa line up perfectly as if they were once a long mountain range. The fourth evidences are from coal deposits. The current location of Antarctica could not sustain substantial amount of life. However, coal beds were formed from the compaction and decomposition of swamp plants that lived million years ago and were discovered in South America, Africa, Indian subcontinent, Southeast Asia. If there is a substantial quantity of coal in it, thus, it only means that Antarctica must have been positioned in a part of the Earth where it once supported large quantities of life. Despite the evidences presented by Wegener, his idea that the continents were once joined together was not accepted by the scientific society until the 1960s. During the 1950s and 1960s, new techniques and modern gadgets enabled scientists to make better observations and gather new information about the ocean floor. Evidence from seafloor spreading. With the use of sonars and submersibles, scientists had a clearer view of the ocean floors. They have discovered underwater features deep within the ocean. Scientists found a mid-ocean ridge in the seafloor similar to those found in the continents. One of these is the famous Mid-Atlantic Ocean Ridge, an undersea mountain chain in the Atlantic Ocean. The ridge is offset by fracture zones or rift valleys. In the early 1960s, scientist Harry Hess, together with Robert Dietz, suggested an explanation to the continental drift. This is the seafloor spreading. Findings that support seafloor spreading theory. 1. Rocks are younger at the mid-ocean ridge. 2. Rocks far from the mid-ocean ridge are older. 3. Sediments are thinner at the ridge. 4. Rocks at the ocean floor are younger than those at the continents. The only problem is that the seafloor spreading theory contradicts a part of the continental drift theory. According to this theory, continents move through unmoving oceans and that larger, sturdier continents broke through the oceanic crust. Whereas, the seafloor spreading shows that the ocean is the actual site of tectonic activity. Evidence from magnetic reversal. Seafloor spreading was strengthened with the discovery that the magnetic rocks near the ridge follow a pattern aside from the fact that rocks near the ridge are remarkably younger than those farther from the ridge. Magnetic reversal is also called magnetic flip of the Earth. The occurrence of magnetic reversals can be explained through magnetic patterns in magnetic rocks, especially those found in the ocean floor. The stripes on both sides are of equal size and polarity, which seem to be mirror images across the ocean ridge. What does this indicate? It indicates that indeed, the seafloor is spreading.
That concludes our report. Thank you for listening.